Thank you. Maybe try to remove this little thing. Hey, yeah, thank you so much for inviting me to visit you today. I'm really happy to be here and met so many nice people during lunch, and also got to reconnect with some people who I've met before, and also people who I've only ever met online before, and now I get to finally meet in person. So yeah, thank you for having me. And as you said, I'm located in Copenhagen for the year, so not too far away. If anyone's ever in Copenhagen, please say hi. And I'm going to be talking about some of my recent work more focused on the intersection between natural language processing and the humanities. I have other research intersecting more with healthcare, thinking more about like reliability and bias measurements. But today I'm going to focus on these data-centered studies that I've done in the last year in collaboration with people in the humanities. And my research is in natural language processing. That's really kind of like my home discipline and where my methods come from. But the other main home of mine is in cultural analytics, which may or may not be a familiar term. So I like to put in a slide at the beginning, kind of explaining a little bit of what cultural analytics is. It's a field that certainly has overlap with computational social science, with the digital humanities, but it's also kind of its own thing. According to the Journal of Cultural Analytics, is the computational study of cultural objects, processes, and agents. I would say in comparison to computational social science, maybe there's a bit more emphasis on the humanities and research questions from the humanities and not just social sciences. So maybe some of the data sources are a bit different. And maybe the methods also are more, maybe lean more toward machine learning and NLP rather than like causal methods, for example, or network analysis, but that's a generalization. But broadly, cultural analytics relies on big data sets and statistical and machine learning methods to answer research questions about human culture. And traditionally, the tools that we use have included lots of NLP methods, especially unsupervised NLP methods like word embeddings and topic modeling. A lot of my prior work has focused on these methods. But of course, now, like everywhere, large language models are unlocking new pathways for the study of human culture, allowing us to approach more difficult, more subjective, and more unwieldy research projects than ever before. And in my work, I like to pose two ways to think about culture and language models. First, and more prominently on the NLP side of things, there's we'll call it the downstream view, where we have a model and a big model, and we use that model for tasks. A lot of NLP is structured around tasks and like shared tasks that we compete on. And thinking about questions of human culture and the topic of today's talk, that task might be something like prompting a model to predict a poem's form, so categorical classification. But upstream of the model, and not always studied on the NLP side, are data sets, curation decisions, text processing decisions, and the actual humans, the human curators and authors of the data. And upstream research uses that same language model, but not necessarily for a downstream task, but to answer questions about the source data set and its authors. For the humanities, and again, for today's talk, what that might look like is searching through pre-training data sets for published poems, and maybe searching for biases in the distribution of those poems in the pre-training data for the model. And it's important to keep in mind that most NLP models and methods weren't designed for these upstream and like cultural use cases. They're usually designed for these downstream use cases and for really, really big data sets. So we might need to rethink some of our methods and the stability of our outcomes, which again, some of my other work touches on more. So I think, as usual, my view is this like data-centered view of language models. Whether upstream or downstream, I'm thinking about data. How can I use these tools to study data sets? How can I dig in and explore the data used to make these tools? Where does the training data for these models come from? What's in it? How do cultural works that are contained in that data affect a model's capabilities? What can we learn about humans from that massive data? but also how can we build good evaluation data sets for humanist research questions? How can we use these models as tools to explore other data sets of interest? These are like downstream questions again, but focus on the cultural use case. These are all data-centered questions, and these are also humanities questions, questions about curation and archives and reception, for example. So today I'll present two first steps toward using large language models for humanities and cultural analytics research questions. Before we can draw big conclusions, we need to test models for their capabilities and we need to build tools. Both of the studies I'll present are data-centered works, but in slightly different ways. They explore the pre-training data for models and how models can be used for data analysis. Also, I forgot to say, for people online, I have the chat window open on my laptop. It might take me a moment to notice that you put a question in the chat. But in theory, I should see your question, so feel free to interrupt me if you have a question. The first study I'll talk about is focused on storytelling. The second project will talk about poetry. In this study about storytelling, I brought together and led an interdisciplinary team to study online storytelling across diverse communities. Our team included computer scientists, law and econ person, maybe familiar to this group, Elliot Ash, and a literary scholar, Andrew Piper, who studies narratology. We had some big research questions going into this study. Our main one was, where do people tell stories online? Can we measure where storytelling happens across many different contexts? But then cascading from that, we had some other big questions. What is a story, first of all? How can we automatically detect that a piece of text contains a story? And how can we do that at scale and across like many different kinds of text data? And our solution to that, our contributions in this study were that we formalized this task of story detection and the task of story span detection. We linked that task of story detection to the established task in NLP of event detection. And we released the first expert annotated data set, codebook, and models for story detection across diverse online texts. Why do we do this? Why do we care so much about storytelling on the internet? There's a lot of studies about storytelling, for example, in a literary setting, but why do we care about online storytelling? It's important for many different reasons. So as a rhetorical strategy, storytelling can drive social movements. It can spread misinformation at the same time that it can be used to educate. As a form of self-disclosure, personal storytelling can strengthen social bonds. It can build trust between community members. It can even benefit the well-being of the storyteller if they're sharing a very personal or like traumatic story. As a sense-making strategy, communal storytelling can help individuals and groups learn about their shared experiences. And this is something that has been studied a lot in online healthcare support groups, for example. And if, maybe I don't need to make this pitch to this group as much, but if you're an NLP researcher who doesn't care about any social stuff, maybe I could convince you to care about storytelling because modeling narratives is, first of all, it's a very challenging task, and we like challenging tasks in computer science. It gives us something to work on, and not all tasks in NLP are challenging anymore. So it's like, good news, this one's still harder. And it's also very important for understanding our pre-training and prompting data. So pre-training data, it's a lot of internet data, and a lot of internet data is storytelling. It's fan fiction, it's people on Reddit, there's a lot of storytelling that's happening in the pre-training data. And there's also a lot of storytelling that happens in the prompting data. So what we've found, for example, in a previous study on people's conversations with ChatGPT is that story generation is one of the most popular tasks that people engage in, and they repeatedly engage in. So these are all reasons to care about online storytelling. And to ground this a little bit more, this storytelling is also scattered across, yes?
Yes, I didn't fully get the definition of what story or storytelling. I mean, are we talking about?
We'll get there.
Okay.
Yeah.
So like news to like actual fiction, nonfiction, yeah.
Any of those, but bring this question back in like 5 slides, I think. And also I'm about to show you an example. So here's an example. This is a Reddit post from I've made it up. It's but it's something like a Reddit post from an online healthcare support community on Reddit. So say that you're a healthcare researcher, you're interested in the kinds of storytelling that people share in these online healthcare support communities. Again, there is research on this, but usually isolated to individual community, always in the past, isolated to individual communities. Maybe you're now interested in storytelling across many, many, many different online healthcare support communities, in which you would like to identify storytelling spans at scale and across these different healthcare topics, which maybe could help you answer questions about the sense-making practices that these users engage in and how storytelling happens, and maybe how that differs across these different healthcare topics. Maybe you want to identify common patterns in those stories, but all of this will depend on identifying what I've highlighted here in purple as a storytelling span. And that requires building and evaluating a story span detection system. Unfortunately, building such a system faces some really big challenges. Stories and non-stories are mixed together across topics and within individual texts. So as I just showed, there can be text that is story and text that is not story. And I'm going to come back to what exactly we mean by story, I promise. But something like this. So we want to be able to separate within a text and across text where storytelling happens. Also, defining stories is notoriously difficult. There's an entire literary field called narratology concerned with the theory of narratives. And prior work doesn't agree. And existing story data sets don't meet our requirements. And I can talk more about each of these challenges if you're curious, but how we address this is to build our own story data set. So how do we do that? We start by developing a code book. So this question of what is a story? What do we mean by story? The research team worked together. We went through many iterations of open coding, discussions, and then alignment. Again, we had an interdisciplinary team that included a narratology expert. We worked iteratively to code data, compare labels, and design a code book containing an operationalization of story that fit our context of diverse online communities and our research goal of measuring storytelling. We were inspired by, but deviated from some important prior work on both narrative theory and, again, this established task of event detection in natural language processing. And we had many difficult decisions. There's all kinds of storytelling that happens on Reddit. For example, sometimes people write what certainly looks like a story, but it's all in the present tense. Or it's a hypothetical story as part of an argument, but it's very detailed and concrete. So the person is trying to put you in the shoes of some hypothetical person. Is that a story? We had to think through all of this. And the long and the short of it is that the operationalization that we hit upon is that a story describes a sequence of events involving one or more people. Notably, as long as a text meets these requirements, we annotate it as a story, regardless of whether it's as short as a single sentence or even shorter than a sentence, or as long as an entire text. And I think it's important to note here, I wouldn't even call this a definition, but rather an operationalization. It's a way for us as annotators to consistently capture this notion of storytelling across text. All right. And I'll just say one more thing before I take it. There are many questions here. What do we mean by people? What do we mean by events? What are sequences of events? The whole code book is on GitHub. So if you have your laptop open, you can go to our GitHub repo and pull it up. It's detailed. But yeah, I'm happy to talk through it. Yeah.
I guess like what is not a story then, given this very broad?
I would say this is pretty specific. So we'll get to like the annotation results in a couple of slides, but about half of the texts that we looked at, Reddit posts and comments, contained a story. So half didn't contain a story. So there have to be specific people, not big groups of people like all Swedish people, for example. There need to be specific people. There need to be specific events. Those events need to happen in sequence over time. So if we don't have those things, then even if it looks a lot like a story, like if there's a lot of like concrete description or story-like elements, we wouldn't count it as a story.
Still wondering hard, like what exactly would fall. I mean, maybe like a manual, but it's not a story.
No specific people, probably.
I have to digest this.
Yes.
What about future? So basically, this definition is not specifying that it should happen in the past. So it can also talk about a story that is going to happen.
Yeah, if it meets, we allow some leeway for the annotator's best judgment. Most of the stories were in the past or present tense, but there are a couple of these like hypothetical, and also I think there is at least one, if I remember right, I think there is at least one future tense story where if it contains enough of these other elements and we included something in the code book, like if it feels strongly story-like, we'll let the annotator annotate that span. Yes?
So when you say sequences of events, this assumes there's like some chronological ordering of the
Yeah.
events. So like something that is about people and maybe even kind of nests a story, but it shuffles the ordering of things. That's not a
Shuffle's
story.
fine.
Shuffled is fine.
Yeah, the
So
events
it just
can
has to be
move
there's
out
an
of order.
implied, even if,
Mhm.
so the ordering has to be implied, even if in the actual narrative, the ordering is shuffled.
Yes, yes.
Maybe one quick clarification to this about the shortest sentence as long as a post. In the example you gave, you have the kind of zoomed in on a particular part of the text. I don't know. Would your identification scheme identify that the story might unfold where it has sort of interjections and describe descriptions of events? I guess one sentence might only describe a set of people, and then another sentence might describe events. And yes, I'm curious how you put the ends on where it begins and ends.
Can people online hear the questions or should I repeat them?
We can hear them.
Great. So I think the question is like, can we have interrupted spans? Like I highlight a sentence or part of a sentence and then I don't highlight and highlight again. Yes. Yeah. What we don't capture and what we didn't observe, luckily, in the data that we had were nested stories, which could be important for other kinds of data, but again, like didn't occur here. And we also don't annotate like which story the span belongs to. There could be multiple stories, distinct stories, or it could be a single story that is broken apart, and we don't annotate that. But it would have been nice to annotate it, but we were already annotating two things. Did you have a question? Okay.
And then, yeah, people. So there can be a story about pets.
Yeah.
So
So
people, pets are people.
Animals, aliens, monsters. We have a list in the code book. There's and we have like a heap problem, right? Of like, when is it too many people? When does it become?
Yeah, if it's a story of two armies attacking each other.
Yeah.
Story. Yeah. Okay.
There's ambiguity here. There's ambiguity.
That's okay. I just.
But yes, pets are allowed as long as the pets are involved in a sequence of events. Okay, maybe I'll show you an example now. So this is a really boring story, but that's kind of why I like this example. So this is an example from our annotation task. So in our workflow, what we did was we first annotated event spans, and then we annotated story spans. So the underlined part here are the event spans, they're verbs, and then the blue highlight is the story span. And the reason for this strong emphasis on events, part of the reason for that emphasis is that we just found it's a very difficult task, the story annotation. Like even at a binary level, does this text contain a story? It's very subjective. It's a very difficult task. We tried it with crowd workers. It didn't go well. And so what we found was that by starting with the events, it helped us add consistency to the annotation, especially across this very diverse set of Reddit texts on all different topics. So we start there, and there have to be multiple events that are connected. If nothing is underlined, then there can't be a story span. So we start there. And again, our codebook allows for these very short stories. And again, this might not be an exciting story. There's sometimes people include in definitions of storytelling a sense of place, concreteness. We found on Reddit that is very rare. I'll go into why I think that is, but just say that. Also that, what was the other thing I was going to say? Oh yeah, there might be some kind of transformation. Sometimes people list that as part of a definition for what makes a story, and we don't include that here. We want to find all of these spans of like event sequences with specific people. Our final, yeah.
Yeah, so I'm still thinking about this example. So going through your definition, the events are the underlined pieces, and then the people here are, we have I've and someone else. Is that right? Oh, and then they. And so I was just wondering in terms of, because I don't know that much about this, is event detection, is this about the types of verbs involved primarily, or is there something else going on there? And then for the people, is this the pronouns that we have here?
Yeah, here, I mean, the main person is the first person singular, which is very common in Reddit posts, is people talking about themselves. And then for the events, yeah, we've got like a long set of guidelines in the code book. But yes, mostly about the verb, and that, you know, it's not something that's recurring. It's not something that's continuous. It's something that happened at a definite point of time, or at least that ended at a particular time. Yeah.
Okay, thank you.
So the final data set includes 500 texts, Reddit posts and comments with these event and story spans, sampled randomly from a much larger data set of Reddit posts and comments. Our inter-annotator agreement for both spans is in the traditional substantial range. This was hard, but we got there. And also the data set might sound small, like only 500 texts. It took a long time. They're long, and each text takes quite a bit of time and effort for individual annotators. It was myself and my co-author Joel who did the final annotations. Again, about 50% of the text included story spans. And after annotating separately and measuring our agreement, we then discussed every single disagreement until we arrived at a single consensus label, which was another time-intensive process, but resulted in what I hope are very high-quality annotations. Now that we have an annotated data set, we can move on to building a story detection system.
Just a clarification, so event spans are like, those are the elements of action in the story. So stories nest events in some sense, maybe not perfectly.
Yes.
Okay.
Events could happen outside of stories as well, like if there were just one event, or events that happen to like sometimes people will like list examples of events that are involving different people.
Okay.
We wouldn't count that either.
But the number of events is greater than the number of stories. It's the main idea.
Yeah, necessarily so.
Yeah, okay.
There have to be at least 2 per story. So we, using our annotated data, we evaluated a bunch of different models. We were doing this all about a year or so ago. So that's why you see these particular models, and also we had limited times. There are more models. I wish we had added some open models, but we didn't. But we used our consensus labels as the evaluation set, the training and evaluation set. And given the small size of the data set, what I'm showing here are results averaged across 5 cross-validation folds. And then the plus or minus numbers, those are standard deviation across the folds. For document classification, surprise, we find the best story detection performance from a fine-tuned Roberta model. So not something like GPT-4, a slightly older model. But the GPT-4 zero-shot and few-shot prompts aren't far behind. And GPT-4, as kind of expected, performed better than GPT 3.5. Also, somewhat as expected, chain of thought prompting provided high recall, but not like consistent improvements. We've seen that for other subjective tasks. Other researchers have seen that for other similar subjective tasks. This isn't to say that you couldn't get better performance using something like GPT-4, Llama, or Claude. There are all kinds of ways to prompt, and there is a finite number of tests that we could run here. But I still think it's really good news, at least for us in this study, that fine-tuned model works so well because it is cheap and you don't need to pay OpenAI to run it. And we wanted to run this whatever method across then a bunch of data. So that would have been quite expensive if we had to rely on GPT-4, for example. For span annotation, we had better performance with the fine-tuned model than with GPT-4, again, in our set of experiments. In general, spans are harder than classifying entire documents, underscoring, I think, also the importance and how interesting that span detection task is. And we also find that our results generalize to some other settings. There are limited other data sets that we can compare to, and those data sets have strong limitations. But if you're curious about that, I can show some results at the end of the talk. Where does that fine-tuned model fail? So for that fine-tuned Roberta model, what we observe are the following categories of errors. So stories misclassified as non-stories. Sometimes these contain cognitive verbs like can or decide or notice, which we sometimes annotate as events using context to decide whether that verb met our other criteria for specificity and sequentiality. Also, there were stories, again, made up of hypothetical verbs, which we sometimes annotated when they were strongly story-like, but the occurrence of those is rare. And also very short stories, like one sentence or less. The model tended not to classify those. And then for non-stories that were misclassified as stories, these often contain general or repeating events. So things that we wouldn't have included as a sequence of events, or describe a state without sequence, but that include other story-like elements, like very concrete descriptions, visual descriptions. They often include pronouns, entities, concrete language that makes the text appear more story-like, but that doesn't meet our story definition. We also have some span analysis, but I'm going to skip that because I love that you have so many questions, but now I'm getting concerned. So check the paper for the span analysis. And we'll get now to some results. So we have our data set, we have a story detection system. We're going to focus on that fine-tuned Roberta model going forward through this next section of slides. And now we're going to try and answer that big initial question that we had of where do people tell stories online? And for our purposes, it's going to be where do people tell stories on Reddit? To structure our results, we followed an open coding approach to categorize 500 of the most popular subreddits into 33 categories. And we use those categories to structure the analysis that you'll see in these results. The most prominent categories are gaming. Gaming is that really big red section on the right. Then subreddits dedicated to hobbies, general subreddits. So those are things like Ask Reddit. Have you got anything? Fandom subreddits dedicated to like books and shows, and then professional advice. So interaction time. I want you to try before you see the results. If we use our fine-tuned classifier and the definition that I've explained to you, or the operationalization that I've explained to you, if we measure storytelling rates in the communities belonging to these different categories, so these are categories that each one could include like one to many subreddits, which would include more storytelling and which would include less storytelling. I'd love to hear your guesses.
Yeah, I would put children pretty high on the storytelling one, because a lot of it is my kid did this, your kid do this kind of stuff.
Okay.
I forgot what it was, what the right answer was, but I remember it last time when you asked me.
You've heard
I
it.
said news and politics.
News and politics.
I could see finance. I
Finance.
think financial advice. I did this on the stock market and then that. I think that's pretty common for it.
Mhm.
I think healthcare as well as I think it's common people to complain or describe their experiences.
Yeah, professional sports, which one is that? Because it's a lot of people engaging in sequences of events, but I don't know how it would be narrated on a subreddit.
Yeah, like some of these might be about storytelling, but not contain storytelling, which is a very good insight and what trips people up about news and politics, for example, which is at the very bottom. So the answer to the question is on the right, the box plots. Those are the categories. And then on the left, the bar plots are showing the individual subreddits, the top and bottom right. So for the categories, what we see very pleasingly are that subreddits dedicated to storytelling are at the very top. And so at the very top here in the bars is our TIFU, Today I F'd Up. That's a subreddit dedicated to storytelling about people sharing these kind of random stories about how they messed up today. And also at the top for the categories are animals, children, mental health, healthcare, addiction, relationships, confessions, drugs. So a lot of personal topics related to healthcare and relationships. At the bottom is news and politics. I think for the reason just described, it's about stories, but not mostly people arguing, not telling stories. But there is storytelling that happens there. It's just relatively less on average compared to the other categories.
Question.
Yeah.
Sorry, I have another question. For children and self-help, are the tiny error bars, is that just because it's very story-centered posting, or is that about the size of the sample, or?
They're smaller.
Okay.
Yeah, and the full set of subreddits with their category labels are available also on the GitHub repo. So if you wanted to know like which subreddits exactly belong to these categories, it's all there. And then, yeah, like professional advice, for example, has a really big bar. It's a big category. Again, like that was one of the categories I noted as being some of the most popular. But also it's just a really broad range of topics. And I think that's the other reason that we see, it's not just the number of subreddits, but the broad range of topics that might be contributing to, and that would include, yeah, like financial advice. And another thing we can do, now that we have this story detection system, is we can map the communities along some fun axes. So here I'm showing the story rate along the y-axis. So it's the same as what we were just looking at. And along the x-axis is the distinctiveness of the vocabulary used in the storytelling posts and comments. So distinctiveness is a measure from prior work that measures how similar a community's vocabulary is in comparison to a background vocabulary distribution. Sometimes that background distribution people try and, I mean, yeah, as a group of like sociology people, you'll probably also find this thing like, what is generic language? They'll use like Wikipedia. Wikipedia is generic language, which of course it has its own particular style, but sometimes the background distribution is just the set of other communities. So that's what we're doing here. So we're comparing how distinctive is the language in this community, the language across all the other communities. It's something like a pointwise mutual information measure. How distinct is the use of this word in this community compared to its distribution across all of the different subreddits? And what we find, first of all, are that categories of subreddits form interpretable clusters. So I've colored here some of the categories that we had annotated by hand before, and they form these nice clusters. And if we look at the corners of this plot, I'm going to show you in a different visualization. It's the same plot, but I'm just going to list things out into the corners. So this shows the subreddits with the most and least storytelling and the most and least distinctive storytelling vocabulary. For example, subreddits in the stories category, such as Today I F'd Up or Glitch in the Matrix, which is another of these like kind of daily stories, like I saw something weird today, subreddits, they tend to have both very high rates of storytelling and low distinctiveness. These are subreddits that elicit stories that don't use consistently distinctive language because they're stories about anything that could happen to you in a day. Subreddits with lots of storytelling but more distinctive topics include hobbies and specialty advice. So yeah, again, really good guess about finance. So skincare, lucid dreaming that makes sense. Has a lot of storytelling, people narrating their dreams and how they like came to the dream state. And tech and mechanics support. There are a lot of like troubleshooting stories happening here. Subreddits that contain less storytelling overall, but generic language in those stories include political subreddits and generalist subreddits. Explain like I'm 5. And then subreddits in the fandom category, like a subreddit dedicated to Game of Thrones, also tend to have less storytelling overall. This is another case of like they're about storytelling, but they're not telling stories as often. But when storytelling does happen, the stories use relatively distinctive language, character names, place names, stuff from the particular fandom. So I think this map that I just showed you is useful and interesting in many ways, but in one particular way is that if you were approaching a question like this with your own data set and you wanted to know, can you use off-the-shelf tools like ours, or maybe you should develop something custom because the language used in your community for storytelling is very distinctive. This is a test that you can run using our data and models, hopefully very easily. And I'll show you one more. Well, do we have time? Okay, I'm going to show you one more result from this study. So this then, we kind of, even though the goal was to study storytelling across many communities, we also wanted to show how you could use our tools and models in a case study of one community. So this is a subreddit called Change My View. I'm going to do this and maybe we'll have to skip part of the next talk because I feel like maybe this group would be interested in this particular topic. This is a wonderful community. It's been used in a lot of prior work. It's also so in some ways very depressing community if you spend a lot of time looking at this data because it's people arguing about all different kinds of political and social topics and raising some of the most upsetting opinions. But the whole point is that it's a place to post an opinion that you accept may be flawed, and in an effort to understand other perspectives on the issue, and that actually succeeds at this. So that's the happy part. This is a screenshot from a while ago where people were debating ice cream flavors, a bit of a more innocent topic. On this subreddit, one person posts their opinion on a topic and then asks others to try to change their opinion. Everyone else competes to change their opinion. They post comments with their best arguments, countering the original post. Hundreds of people sometimes, maybe even like thousands of people for some of the most popular posts, using all different kinds of arguments to change the poster's view. And if anyone succeeds, the poster can award a delta point. Delta, they change their view, to that comment, which is recorded publicly and it is available to researchers. Amazing. And there's been a lot of prior work done on this subreddit because it is such a nice data source. But we're interested specifically here in where storytelling occurs as a persuasive argument. So in this plot, the x-axis is showing post topics. We use an LDA topic model and then applied manual labels to those topics. That's what's shown along the x-axis. And the y-axis shows the difference in topic probabilities between storytelling and non-storytelling comments. In other words, it tells us how many of the comments replying to posts on that topic use storytelling. Higher bars indicate more storytelling in the comments, and lower bars indicate less storytelling in the comments. So again, this is the topic of the post, and this is the amount of storytelling in the replies. And what we find are that social and personal topics like lifestyle choices and music receive more storytelling comments. And that makes sense also in context of the results I just showed you about the ranking of the subreddits. While abstract topics like economic systems receive fewer storytelling comments. And to be clear, like these patterns are likely driven not only by that topic's subject matter, but also by the particular framing and audience in this subreddit. So for example, there's a topic for ethical animal treatment that doesn't contain that much storytelling relative to the other topics. But I could easily imagine in another context that it would elicit a lot of storytelling. Like I think if I were arguing about ethical animal treatment, I might tell personal stories about my pets or something, or experiences I've had with animals. So this is something particular to this community. I'm not making any broader claim about whether there's more storytelling in general about for these topics outside of this community. Okay, so those are the topics that receive more storytelling comments, but was storytelling actually a useful strategy? I'm just going to show an initial result. This is just a little case study to show what we can do. But what it seems like is that no, those aren't necessarily the most persuasive strategies. So here it's the same topics, they're just reordered now. I'm again showing those same post topics on the x-axis, but now the y-axis shows the difference in proportions of winning comments that contain or don't contain stories. So higher bars indicate that more winning comments contained stories. And examining some of the outliers here compared to the previous plot, we find that for topics like drug legalization and race, storytelling comments are more likely to be persuasive than for the other topics, even though commenters are less likely to use storytelling in their comments. So maybe they should use more storytelling. Conversely, topics related to traffic accidents and music receive many storytelling comments, but those comments are less likely to win. I'm not sure if it's the reason, but that kind of, I have some intuition there, like music, like I don't like, who cares why you like the music? That's not like a persuasive argument. It's very personal, right? It's like too personal maybe. So there's a lot more to explore here. You might also notice that most of these bars are below 0, indicating that storytelling generally wasn't a good strategy. But there's like many more factors that we don't explore and that would be good to explore in future work. For example, just thinking about storytelling, breaking apart stories into personal stories versus non-personal stories. Maybe we have different categories of stories. Maybe some of those, maybe personal stories are more persuasive, but we don't explore that here. What we want to show in this example is how our data set and models can enable different kinds of community-specific analysis as well as that inter-community analysis that I was showing before. Yeah.
Yeah, so I have a question. I'm not sure if it's right, but I'm thinking about the concept of storytelling itself. So are you trying to unpack the way you tell stories? It seems like you have like almost like a lever here. You think storytelling is just more or less of the same dimension.
Yeah.
Whereas, storytelling, if you think about, I don't know, Stephen King's book about telling stories, just like everything suspense to the way you use, like, I don't know, descriptions of events. So storytelling is sort of multi-dimensional.
Yeah, for sure. Yeah.
So how do you think about that versus what you're doing here in terms of storytelling as an expert?
Yeah, we're ignoring that completely. Again, we have these like really boring stories, like I showed, where it's like this one sentence that probably most people wouldn't label as a story, mixed in with things that would look more like Stephen King, like really descriptive.
I can imagine like traffic accidents. If you ask Stephen King write a story about traffic, I can bet you he'd write some reviews.
Yeah, and within the subreddit, those might be more religious stories. They might be more emotional stories.
Yeah, exactly. Yeah.
Yeah.
And so it seems to me like you might be able to disentangle this. It's an interesting step, but if you have like a linguist sitting here, storytelling is just one dimension, they might go like, "What are you talking about?" But I'm thinking, ways of extending this approach to maybe measuring more dimensions and why certain, storytelling techniques are better than others in different domains. Just like talk us through how would you measure that with your approach?
So we have some that span analysis that I skipped over. So we have some feature analysis of the storytelling versus non-storytelling spans that doesn't directly answer the question, but like gets us one step of the way. So like measuring concreteness of the language used, that's one of the features there. So in general, there's more concrete language in storytelling spans than outside of them, despite what I said but less concrete than in a literary setting, for example. But yeah, you could absolutely you could break apart these stories into all different kinds of categories. Again, sentiment arcs, the types of people who are involved. Is it a first person story? Is it a reported story? I heard from someone else, or I read this in the news. Is it a fictional story? Like they're arguing about Batman, which there's a whole topic category here where people are doing exactly that.
So what we did, like methodologically, imagine that, I don't know, if you find like, this is our archetype of typical storytellers, like Stephen King, say, or someone, a bucket of authors, like these are great storytellers, and you would sort of maybe fit some kind of an embedding over their way of telling a story or some kind of a measurement of anchoring them, and then you would say, compared to this reference point of masters of storytelling, like how far off is this particular story, that particular story, and then you have sort of then you have a measurement that I can at least understand. Like, okay, so it's like storytelling in the sense of this bucket of authors, right?
Yeah, I have
So
lots of thoughts, but you might then like, so we have a follow-up paper at NLP last year where we compared our annotations to very unstructured crowd worker annotations. So not giving them any much guidance at all and just saying like, does this contain a story? How did you make your decision? What about the text, indicated to you that it was a story or not? And then did some qualitative analysis of the reasoning that they reported. And there are divergences for sure from our researcher annotations. And yeah, we've got a whole paper just about that.
Mhm.
So maybe that would answer some of your question.
Yeah, I don't know. I mean, it's an interesting attempt, but it's just like, it might
Yeah.
be a bridge. So, but I'll let you go and then we can come back to that.
Yeah. Okay. Future directions, yeah. This work, I think, is a jumping off point. Like, actually, we came into this work thinking we had this question around like, where do people tell stories online? And we thought we would do probably much more of the fine grained analysis that you're proposing. We thought we'll find the data set off the shelf, fine tune some classifier, and we're off to the races. And instead, there was no data set. It turned out we had all these thorny questions about what even are stories? What do we mean by stories? But now that we have this, then we can do this like deeper social media analysis, for example, about also community features. So communities that have more toxicity, communities that have more loyal users, like all the computational social science studies of online communities, we can tap into some of that and think about how that relates to storytelling. Also, how storytelling can drive misinformation. That's something interesting I'm very interested in right now. Also, variation in storytelling perceptions across different demographic groups, as I was just describing. And analysis. So we did all this work for the event annotations, and we haven't really gone deeper there, but we've talked to people who their whole research thread is about events and verbs, and especially on the linguistic side. And I think we should do more with those, or someone should do more with those event annotations and the relationship between those annotations and causality, sequentiality, and storytelling. So again, the contributions here, formalization of the task, releasing the dataset codebook and models. They're on GitHub and on Hugging Face. I hope they're easy to use. Feel free to contact me if they're not. And this inter-community and also a single case study of an intra-community analysis of where storytelling is used as a rhetorical strategy. And yeah, this is the follow-up paper that I mentioned. So if you're interested in crowd workers and this like diverse perceptions of storytelling, digging deeper into, like what do we mean by storytelling? This paper would be a good one to look at. Okay, we are at 50 minutes. We've talked a lot, so I feel like it's fair for me to dig into the question time at the end. And I would like to talk to you about poetry in addition to storytelling. Any final, maybe just kind of like clarification questions on the previous study before I move on? Okay, so from stories to sonnets. This is another collaboration with humanities scholars, but different humanities scholars and on a different topic. This was a collaboration with two digital humanities scholars at the University of Washington. Both have degrees, PhDs in the humanities and expertise in poetry, and also poetry's popular reception, and in particular on the internet. And Melanie, my co-author, she had noticed something interesting happening in the news. So when journalists, social media users, marketers, and even developers of large language models, when they're publicly discussing the capabilities of these models, they like kind of weirdly often talk about poetry. For example, Google named its first chatbot Bard, which is a traditional term for a poet and also the nickname for William Shakespeare. Anthropic named its 2024 Claude models after popular poetic forms like sonnet, haiku, and opus. Generated poetry was one of the first large language model outlets to go viral on social media and remains popular there. I can also say for myself, first time trying ChatGPT, I had it generate a poem about my dad. It's something going on here about poetry being the touchstone. The first test. And Microsoft released an ad that featured its big chatbot writing poetry, as well as a whole instruction guide for how to write poems with Copilot, including a list of suggested poetic forms to try. So like why are they talking about poetry when they're talking about these new models? And there's some, I think, obvious answers, like poetry is a signifier of human creativity and complexity, as well as a popular and culturally significant art form with a long history. It's a lightning rod somehow for the marketing and popular imagination of these big models. And also that's not new. I think as long as there's been natural language processing, like people using computers to generate language, they've been trying to generate poetry. But still it's interesting, and that sparked some questions. In this study, in a nutshell, we wanted to poke at this notion that models know something about poetry. What do they know? What can they know? And going back to the data-centered questions, what kinds of poems were they trained on, and where did that data come from? We decided to use a single task, poetic form classification, as a lens into these questions. And in this study, what we ended up doing were introducing this task of poetic form detection, which I will explain in the next slide, with a comparison to a formative human study of poetry experts. We include benchmark evaluation experiments for a suite of large language models, analysis of poems found in popular pre-training datasets, and code, data, and metadata released to the public on our GitHub repo. The form classification, form detection, like what is this task? Our task looks like this. We show you a poem's text and ask you to classify it into a form category. Is it a sonnet? Is it a ballad? Is it a haiku? Traditionally, form refers to the manner in which a poem is composed as distinct from what the poem is about. You can think of forms kind of like genres of poems. Poetic form can be defined by particular patterns of sound, referred to as prosody, by visual patterns, features like rhyme, repetition, meter, and topic, so it's a bit confusing, fixed length, and visual form. So depending on the form, some or many of these features may be used to categorize it. And in scholarship on poetics, forms are fluid and sometimes overlapping, just like literary genres. Forms are socially and historically constructed, and they've been the subject of heated debates, while also having remarkable durability across time. Some of the forms that we test here originated over 1,000 years ago. This all makes it really difficult and subjective to evaluate poetic form, but we're gonna try. It's a good test for these models and a good test for humans. And I will also preface this here as I am not a poetry expert. Luckily, I had 2 poetry experts on this paper, but if anyone here is a poetry expert and you start to dig in really deep, I'm gonna have to point you towards Melanie or Anna. But let's start with some examples. I want to establish that this isn't an easy task, not even for humans. So we did do a very small human study of poetry experts, people with PhDs in literary and poetry studies, asking them to try it out on a small set of poems. And I'm going to show you some of those, 2 of the examples. So here's a relatively easy example. For those familiar with, I'm sorry, they're English poems, but not as fair, I'm sorry. But yeah, any ideas what form this poem is?
Sonnet?
Sonnet? Yes. It's a Petrarchan or Italian sonnet. So it is slightly, there's a little bit of difficulty here, and you can see that in the results with the experts. They didn't all get it right, but most of them got it right. So that was an easier example. Now let's try a hard one. Any ideas what this form is? It's very hard. And it's also a trick because I'm withholding some information like the title, which would help you. It's a haiku, apparently. Again, I'm not the poetry expert here. So it doesn't have the 575 meter and 3 lines that I think we're popularly familiar with. But scholars have said about the haiku that the English haiku is both as recognizable as 575 meter and as amorphous as a shared sensibility. That's hard. If a reader is engaged with the history of haiku, apparently, they will recognize the reference to Busan in the title of the poem, Busan is was an 18th century Japanese poet who's recognized as an early master of the haiku form. And so if you knew that, you might know that this poem at least has ties to haiku. However, if you encountered the poem without the title or the author name, as our survey respondents also did, it would be a lot harder to recognize. And so you can see that our experts were all over the place. About 33% of them got it right, and the rest of them didn't know what to do. So again, form is complicated. Forms are contextual and overlapping, and this task of form classification is hard and subjective, even for experts. To set up the task, we first need a bunch of poems that are labeled with their forms. And this labeling task is hard, but in this case, luckily, we're going to skip over it. Doesn't mean that it isn't hard or that there might not be problems with these labels, but we're going to adopt the labels already applied by some established poetry organizations. So we scraped data from first the Poetry Foundation, which is a nonprofit that runs Poetry Magazine and also hosts an online database of English language poetry. We also gathered data from the Academy of American Poets, another nonprofit that hosts the website poets.org. And we also included some manually digitized poetry books because we had some early feelings that model memorization might be a problem. We'll come back to that. Notably, all of these they mostly include English language poems with a focus on North American and European poets. Overall, we curated about 4,000 poems, which have been already tagged or categorized by human annotators with their form, either published online or collected in books. And a poem can have multiple forms applied to it. And
why did so many drop out from those like 60,000?
Melanie did the data collection. We just didn't run the scraper over the whole data set, but we are currently this week working on a maybe ACL submission that would include a much larger data set. Many of those poems are copyrighted. So we would not be able to share them, but of the 4,000 here, we released about 1.4 thousand that are in the public domain. So we released those poems with their form annotations, as well as some other accompanying metadata, such as the subject tags, the author's birth and death years, and some other data like when available. We don't make any of the in-copyright poems available for obvious reasons. And hopefully that public domain set that's publicly available will also increase soon. Yeah.
Question. Is that so public domain in this case, is that mainly governed by the year of publication?
Yeah.
Okay.
Yeah, we're taking, I think, like the strictest view.
Okay.
Because we're afraid. We test 6 modern language models listed here. Ranging from more to less open. And we use zero-shot prompts with different amounts of information from each poem. So we try out this form classification task showing the model just the poem text, just the poem title and author, just the first line of the poem, or just the last line of the poem. And I think it will become clear when I show you the results why we are trying out these different methods. In particular, we're using, just zero-shot prompts. So in the previous study, we were trying to design a really good classification system. We wanted something reliable, we could run on a lot of data and have some, some trust in the results that we were getting after running the classifier. Here, our goal isn't to create a great classification system. First, we would try few-shot prompts and fine-tuning a model and all kinds of other things. We're trying to learn about the model itself and about its pre-training data rather than trying to build a perfect system. Still, there are other tests we could have run, but given limited time, we only did zero-shot prompts with these different amounts of information. We have so many results in the paper, like huge tables of numbers, and I feel like it's overwhelming to look at slides. But if you want to see them, they're in the paper and in the appendix, there's just table after table. But I'll try and summarize some of that here. So when prompted with only the text of a poem, the models perform better overall on what are called fixed poetic forms than on unfixed forms or formal elements. Classification performance in particular for sonnets and haiku is high, with F1 scores near or over 0.9 for all the models except Llama 3. There could be multiple reasons for this, which we will look at on the next slide. Yeah.
Yeah, this is just my ignorance showing, but what's the zero-shot prompt?
Sorry. When you give a prompt to a model, you can show it examples of what you want. So in a traditional machine learning setting, we would show hundreds or thousands of examples. That would be fine-tuning or training, going back even further. And when we instead just use a text prompt, usually what you would do is show maybe 3 examples, or you can show no examples. So here we just say, what is the form? And list the different kinds of form and the poem text. Or we could show examples, like here's an example of a sonnet, here's an example of a haiku. So in this case, we don't show any examples. We're not trying to teach it. Yeah, maybe that's the way I should phrase it. It's like, we're not trying to teach the model anything, we're trying to elicit from it what do you already know. The models generally struggle to identify forms based on repetition. But GPT-4 and GPT-4o do well on this more uncommon poetic category, especially with sestinas and pentumes. Poetic forms based on topic prove more difficult for the models depending on the topic. So forms that are centered on more concrete subjects like death and art are more often recognized, while poems about abstract ideas and styles are harder to classify. There are fewer forms, like far fewer forms in our data set that depend on visual features. So you can think of poems that are kind of like arranged on the page in like a shape or something. And most models, except GPT-4 and GPT-4o, don't do well with those, which totally makes sense. And again, we make no effort here to like teach the model how to do it or to use a vision or multimodal model, which you could. So it makes sense that they struggle there. And they also struggle with concrete or pattern poetry and prose poetry. So poetry that doesn't have line breaks and it looks like prose, looks like non-poetry text. Now, let's think about model training data and memorization. So as with any classification task now, if you're using big models, like GPT-4 or Claude or Llama, they're trained on as much text as they could possibly gobble up. And that's a lot of internet text. And what that includes is your machine learning data sets, for example, and also poems. So we're worried that, or not worried, but like interested to know how memorization might be happening for this task. So I'm showing here our results when prompting with just the poem's title, the poem's author and title, just the first line of the poem, or just the last line of the poem. So those are the different colors. And what we see is that when prompted with only the author and title of the poem, no text at all, the models achieve nearly as high or higher classification performance in some of the categories. So for example, sonnets, they're the one that stands out the most here. That's this one. Oh no, like why do those bars all look like the same height? That shouldn't be happening. For a human, that most likely wouldn't be happening. But why is it happening? There are a few things going on with sonnets. First, and what would also help a human, is that more than 40% of the sonnets in our data set include the word sonnet in the title of the poem. So if you have the title, unless they're trying to trick you or something, it's probably a sonnet. But that's only 40%. It doesn't explain everything, and it doesn't explain the first line and last line. There might be lexical patterns. I'm sure there are lexical patterns associated with certain forms. So again, certain topics might be more associated with sonnets than with other forms. Maybe even the author's name, maybe something about the author's name is indicating sonnet or not sonnet. But it doesn't account for all of the performance that we're seeing here. So it seems likely that the models have already seen a lot of these poems during their pre-training. The results are suggesting possible memorization. Was there a question already?
Yeah, I mean, I was sort of wondering about the strictures of the form at line level, right? So with sonnet, I mean, the fact that it's iambic pentameter is gonna, I don't know what the model is doing, but at least a reader could recognize that. And then, you know, your best guess would be Sonnet. I don't know what these other forms.
Classifier, it would totally make sense, right? Like the count of the words as a feature. When prompting and without showing any examples, I mean, we don't do any interpretability tests here to poke at the model internals, like kind of who knows how it's making the decision. But yeah, for sure, that could be a clue. It would be a clue for a human as well. Just to see the first or last line. So this leads to this question of what's in the training data. These memorization issues are concerning, they're interesting, and we want to go back to our original questions about what models can know about poetry. Presumably they could only know about poetry what they've seen about poetry. So investigating this requires diving into the pre-training data. That data is usually hidden by companies for a variety of reasons, including both protecting their secret sauce that makes their models so good, and of course, possible legal repercussions for using copyright data. There's been a lot of attention on book data in pre-training data sets, but what about other cultural works like poetry? So for prior work, for example, there was this retrospective description of one of the major books data sets that's been used in pre-training data. There's also this study of books memorization that relies on a character name close test. So mask out the character name in a piece of text and ask the model to fill in the character name. And if there weren't other clues in the sentence about who that character could be, it means the model has seen the sentence in the context of that book before. There's also this one study of poetry memorization, which we take some inspiration for some of the tests that I'll show you next. We relied on two open resources, both from the Allen Institute for AI, where I was working while doing this study, DOLMA and What's in My Big Data. DOLMA is a 3 trillion token English corpus built from a diverse mixture of web content, scientific papers, code, public domain books, social media, and encyclopedic materials, resulting in a large pre-training data set. This was the pre-training data set used to train OLMO, the open language model from AI2. And it is open to completely open to researchers. And to explore that data set, because it is enormous, it's an engineering challenge on its own just to query for things, we use a package called What's in My Big Data by Yanai Elazar, who is a fabulous researcher, and I'm really obsessed with this library, this Python library that lets you explore this data set. So it lets you search for exact strings and return all matches along with their associated metadata in that DOLMA pre-training data set, including the data source, the original web domain, the surrounding text, and some other information. So I really highly recommend these two resources if you're interested in big models and their training data. Maybe you have data sets that you would like to know, are they literally present in the pre-training data? And what we find using those two tools, so searching directly in pre-training data sets, is that about half the poems are not present in DOLMA. About half the poems in our data set are present in DOLMA. So that means not even one line of the poem could we find an exact match for in DOLMA. This doesn't guarantee that those poems aren't present, especially for industry models whose pre-training data is not disclosed to us, and which likely include many in-copyright texts that are not included in this open data set, but it gives us one publicly available clue. And what I'm showing here is that overall, if at least one line from a poem is found in DOLMA, it's likely that all the lines of the poem will be found in DOLMA. This figure shows the forms and the proportions of their associated poems that were detected in DOLMA, categorized by the DOLMA source. So these are the poetic forms like haiku and sonnet, and these are the data sources like Project Gutenberg or Common Crawl. About 30% of our poems are found in the Common Crawl data, included in DOLMA, with the C4 dataset close behind. And interestingly, some sources like Project Gutenberg only contain significant percentages for certain forms. So like there are a lot of ballads and couplets, but not a lot of the other forms. This seems important. So models trained on different mixes of these sources could be more or less capable of recognizing and handling certain forms over others. Another fun thing we can do with this tool is examining the web domains from which the DOLMA data was sourced. And what we find are that large websites like GitHub, Reddit, and Google Books dominate the rankings. There are also many poetry-specific websites like poetry.com and also poets.org, which is one of our data sources. Those are present in the top ranked domains, as are domains related to books. Like there's so much more to explore here that we didn't explore, thinking about like where poems appear online, how they spread and are shared, and which poems or lines are most quoted and in which context, like totally other research questions related to poetry and popular reception of poetry, the spread of poetry online that you could use these tools for. But that was all reliant on that open pre-training data set. What about closed models whose data we can't access? Can we learn anything about those models? What we do there is we replicate tests from the paper I showed earlier by prompting GPT-4 to produce the next 5 lines of a poem, given its title, author, and first line. And what we find there, and it's a fuzzy match at the end, what we find are that 42% of the poems seem to have been seen already by GPT-4, where it was able to complete the next line. Of those, 36 of those seen poems are also present in DOLMA. So what it all means is that there's a lot more poetry data available to the closed models like GPT-4 than is available in open resources like DOLMA, and we all know why. Yeah, question? Or okay, I'm following. Yeah. I'm going to show you one result table. Numbers. So going back to that form classification task, we can categorize our poems by likely memorized or likely not memorized, or likely seen or likely not seen. So in each pair of columns, I'm showing on the left likely memorized, and on the right likely not memorized or seen or not seen. And what we see roughly is that performance seems to drop across most models and forms on the likely not memorized poems, indicating the importance of exploring this possible memorization question when thinking about performance results like this. It also helps us understand that much of what these models know about poetry is simply memorization or having seen the poems before during training, rather than generalizable understandings of poetic forms. There's so much more that can be done here, like a much fuller statistical experiment to test for correlations between memorization and performance. But this is the last result I'm going to show you. And I'm so sorry, but I need to plug in my laptop. It's about to die. So maybe you can just stare at that result table for one moment. Sorry. Is there an, okay, yeah. Hopefully it will reach.
Yeah, there's also this. Yeah, and also in the table, I think that's one as well.
Okay. All right. We're almost done. Just some implications now from this. Oh, yeah, question.
Can you just remind me exactly how we quantify memorize or not, just like technically?
Show GPT-4 specifically the title, author, and first line of a poem and ask it for the next 5 lines. And then we do a fuzzy match at the end because sometimes there might be like small punctuation differences, but which I feel is fair, like maybe there's a couple characters difference, but I'm still gonna count, like if it can mostly complete the poem, I feel like it's probably seen it before. And all that data is also available on our GitHub repo.
Yeah, okay. And how would you rule out that, like, I don't know, if you have thousands of potential ways of writing that sort of overlaps typically with your query?
Sorry, could you explain that a bit?
Well, I mean, you think about the subset of potential ways of writing exactly the query that you're testing for.
Oh, yeah.
So like, you know, even if you think like,
Yeah.
see what I mean?
Yeah. It's a fuzzy match in general. It could be missing. For sure. There could be poems that it doesn't complete correctly
Especially
for whatever reason. Yeah,
So it's just basically, you're just relying on that. There's no probability of like, you're not getting a number out. You're just
you
checking.
can't. There are no numbers. That's the problem, yeah.
Yeah.
For another kind of model, you could. Or for another kind of model like Olmo, which the data set is available, you can just search directly. But for something like GPT-4, this is what we are left with, and it's what the lawsuits are left with.
Yeah, because I find that's really interesting how we think about the memorization problem.
Yeah, me too. And so we have a new paper that's just accepted at NACL, like focusing more on these closed tests. So in the past, those closed tests, so that's where you mask out like a character name. But that only works with like fiction books with character names. So we tried to generalize that. So looking for sentences with high surprisal, tokens with high surprisal, and just masking out those high surprisal tokens. So that's something you could do for any kind of text. So that's something that I think if you have data where you're concerned about this, I think you could use that test on pretty much any text data.
Right, you couldn't ask it like, have you seen this sentence before?
I mean, you could, I don't know what it would.
I mean, you could lie, but
Yeah, I mean, it would.
hallucinate or whatever you
Percent
call
of the
it, yeah.
time, yeah.
Okay.
I mean, it'd be nice, to like run tests like this. It's just, we have, so, yeah, in the NACL paper, this is all like a really interesting and hard problem.
Yeah, no,
But you can try and like, if you know the model cutoff, and so books that are published before that cutoff versus after that cutoff, that gives you some kind of, it's still not perfect. You don't know for sure that they included those books and you know for sure that they didn't include the books that were published afterward. So
yeah.
that's what we use in the NACL paper, led by Abhilasha Ravichandar,
Yeah.
who's on the job market. It's amazing.
Yeah, okay. Now I'd love to see more work about this, like what does it mean, how do you test?
Yeah, I also just heard a talk, someone from the University of Edinburgh, so I'm blanking on her name right now. She's a PhD student there that thinks about memorization, but from the sense of like model internals and like interpretability. I posted about her on Blue Sky and can find her name later if you're interested, but I found her talk about model memorization to be useful.
Because you have to sort of separate it out from learning, right? Because like it could just have actually learned to generalize well.
Yeah.
Right? And you can just testing for that. And there's nothing about memorization here. It's just about learning to generalize.
Exactly.
Right.
And we want it to generalize, I guess.
Yeah, exactly. The numbers might be very good.
Yeah.
So like I don't know. That's sort of the conundrum.
Plausible deniability is built in.
Yeah, there's a lot to think about here. So I'm just going to wrap up really quickly so that we have a little time for final questions. So kind of big picture takeaways, some implications here for poetry researchers, readers, and digitized collections. First of all, these evaluations, I think, can offer scholars insight into the legibility, durability of different poetic forms, as well as how forms relate to each other. There's also interesting things here that we didn't fully explore, but that could be a whole set of papers on its own around circulation and reception of poems on the internet. So viewing these models as snapshots of human culture and online culture, where poems appear in training data is often where they appear online. So you could use these models as a lens into those kinds of questions, or the pre-training data sets as a lens into those questions. For NLP researchers, I think that, first of all, collaborations with humanities scholars can enrich studies of model capabilities and pre-training data sampling. So all these like memorization questions, not that they don't come up elsewhere, but they come up in a very specific way for this particular problem, and in a way that I think is helpful to NLP research. Also, evaluation of systems to detect rhyme, meter, topic, repetition. These are features that are unique from if you were interested in categorizing prose genres, for example. So this is a nice evaluation task. And finally, designing these kinds of benchmarks is hard. Memorization is an uneven issue that's difficult to quantify, and we need more open resources and open models for auditing pre-training data. Some ethical considerations. So again, we only release poems that are in the public domain whose authors died before 1929. There are a lot of existing biases surrounding poetic form. So for example, women are underrepresented, and also discussions of like innovative poetry in the US often constructs some of these categories as implicitly white. So that's something to keep in mind. And also the models themselves may be biased towards the English canon. So poems that are popularly taught that appear in more books because of these anthologies and like books included in the pre-training data for these models. Future directions, better handling of white space, both in data set creation and analyses and modeling. That's something we're working on right now. White space is very important in poems in a way it's not necessarily important for other kinds of text. Better memorization tests, like in our NACL paper, please check it out. And further exploration of pre-training data sets, again, considering them as cultural snapshots to let us study the spread of poems online and across data sources. And remind you that these were our contributions in this study. You can find everything that isn't copyright in our GitHub repo and many more results in the paper. And I'll end with just a couple thoughts, like broader thoughts about these two studies and about bridging between AI or NLP and the humanities. So I really think we need these kinds of deep collaborations, co-authoring collaborations between humanists and computer scientists, not just computer scientists taking something from the humanities, but actually working with researchers in the humanities, and also projects where the humanists are leading the project and we are the support as computer scientists. We also need people working both downstream and upstream. Data is important. Somehow, even though we know data is important, that work is still often devalued. Data matters. And a small rant kind of coming from the NLP side. There's a lot of focus. There's been a lot of focus on things like bias measurement in data sets. There's now a run on work on cultural alignment, value alignment, and nationalities. And culture is about so much more than just value alignment and nationalities. There are important problems and possibilities brought by these big models that go far beyond bias measurement. Books, art, poetry, history deserve careful consideration by computer scientists. Questions around reception, poetic form, storytelling. I think these are all important as well. And I'll end with this quote from Alison Gopnik that she said in a talk at ACL in 2023 that I still keep coming back to, that large language models are the newest version of cultural technologies like language, writing, libraries, internet search, and Wikipedia. To me, this means we can study these models in the same way that we study other cultural technologies and human curations, and in the same way that we use those as tools for studies of human culture. And that means we can use these models to learn about questions, research questions in the humanities. These are human research questions, and we need collaboration. That is all.